This is Saxon, Advanced Math, Lesson 97, and this is dealing with the ambiguous case. Now, I'm looking at this first example, and I want us to realize what an ambiguous case is. An ambiguous case is something that I can't solve down to one solution. It doesn't give me enough information. And so we have two sets of possibilities with ambiguous case triangles. So our example 97.1 says given A is 40 degrees, little a is 4, little c is 9, and they want us to draw and solve. So we know that first of all, I know that, for the triangle inequality theorem, that the smallest it could be is 5, and the largest it could be would be 13 for this to work. And so I start plugging these things in, right, because that's 4. And so I got a problem though. The smallest it could be is 5. And the biggest it could be is 13. Okay, so let's start working this out here. If I used the Pythagorean, or the triangle, and set it, well, what would the height be? So I don't know what that third line is, but what if it was a right triangle, and I used the sine of 40 to find the height, right? So sine 40 equals h over 9, and then I said, therefore the height has to be 5.79. This is where my issue comes up. Because if my height is 5.79, okay, and I have a 4 as my A, right, that goes with this one, the opposite to it, that means this little 4 is too short to reach the height. He won't reach on this side, he won't be to the right, and he won't reach over here. So no triangle exists. And that's the first thing you want to check on these. The next thing is 97.2, and it says draw and find the missing parts. And I've got A is 27 degrees, A is 5, and B is 7. I do the same thing, right? And I find the height is going to be 3.18. That's easy enough. That's just using the sign and finding the height. The height is 3.18. Well, that's no problem because I have a value of A of 5, so that's okay. So I know that my height is going to be 3.18. But here's where the ambiguous case comes in. If I made this a right triangle right here and said that my height, right, was 3.18. That means that there's two different directions that my number 5 side could go, because that's the A side that goes across from the 27. It could go this way, or it could go this way. So I have two separate options I have to explore. Well, if it came in close this way, this angle ends up obtuse. If it comes out up here, it ends up acute. If it's this way, this one's acute, and that one's obtuse when it was open. So let's start exploring both. And I use the same trig function to find out that it's 39.46 when I plug that in the calculator. But I realize that there's a second quadrant answer as well, and that would be at 140.54. That's 180 minus my first quadrant answer. So I have two possibilities that this would work, and that's if it's closer or further away. Okay? If it's closer, it's obtuse, it's 140, and if it's further away, it's the 39.46. So I take my options and I say, well, if it's 140.54 and 27, if I subtract those from 180, I'll get 12.46 for the other one, which means that this little piece here, if it's coming in closer, is only a 12.46 angle. And then I go ahead and solve for the other sides, right? Well, if I know that that's 12.46, I know that's 140, I know that's 27, I know that's a 7 and 5, I can use my law signs to find my last one, which is 2.38. But what if it's option 2? What if it goes out further? Well, if that's true, then it's a 39.46 and a 27, so I subtract those from 180, get my 113.54. Use the same thing, right? The law of sines, 5 over sine of 27, but I'm going to be using 113.54 instead of 12.46, and that gives me a length of 10.10. So here I've redrawn my two triangles, and I did use those labeling here, but these are the two possibilities of a 27 with a 7 and a 5. It can be closer, and that makes it a 2.38, or it can be further, making it a 10.10. So the reason why this is an ambiguous case is there are two possibilities that it could be, right? It could be this one or this triangle, given this information. So I have to solve for both ways. And it's not too hard as long as I remember that I do have two possibilities because the sign is positive in both the first and the second quadrant. It could be there that when I use the law of signs, there are two possible answers that it could be. First or second quadrant, I have to use and explore both options for this to work. Now, there's a little bit of a key here, and that is that you must find the height first. If your height value, if this value here, is longer than your opposite value of your given angle, it's not a triangle. And that's what happened on case 1. If it is shorter than it, great, it works. There's two possible answers. If it happens to be equal to it, what would that mean? Well, if it was equal, you've already solved it, it's a right triangle. So there's that possibility as well, and that's why you want to use that law of signs right off the bat, use the sign function right off the bat to solve to see if this is even a possible triangle.